Learners to Smart Teaching Online. Today, proudly sponsored by Basic Education, VT Africa Holdings, Fibertech Distributors, and Vastratech. In order for you to be part and parcel of today's assessments, you have to log in to www.hellosmart.com. Sign up as a guest, type in your ID. Your ID is 598751. Add your name. So welcome back to physical science lesson. Yesterday we were busy with a problem of work energy theorem. So we tried to analyze it, write down all the given information on that data. We have done some calculations. As you can see here, we're still busy with a car of mass 1,800 kilogram, which is initially at rest. It tells us that the initial velocity there is equals to 0. Okay, now free wheels down a slope with an inclination of 35 degrees. In other words, we've been given the angle theta, which is 35 degrees. If the coefficient of kinetic friction is 0.3, we talked about this. This is value of mu, and then it tells us that we have kinetic friction is always opposing the motion of an object. Okay, they requested us to calculate the velocity of the car once it has traveled 75 meters. In other words, they gave us even the displacement. Okay, that is the distance covered. If you can just look at that, that is how we have the object, and this 35 degrees there, that is horizontal, inclined. Then we wrote down our data, the given information, where the mass was 1,800 kilograms. The initial velocity there is equal to 0 meters per second because of rest. Theta there is that 35 degrees. Don't forget, because we are dealing with the f of x all the time, your theta then is equal to 0 degrees. Don't be confused of this given theta and the theta that we're supposed to know, because this is the x-axis. We have a positive side and a negative side on the x-axis. Okay, now we have this value of mu, which is equal to 0.3 without a unit. I told you that this one is because of the ratio, we can't just have a unit. Okay, and then the distance there, which is 75 meters. And then what we have the final velocity that we are looking for. Okay, I tried to use the free body diagram so that it will be clear to each and everyone. I hope you have this in your books. We have the normal force indicating the normal force. We have F of G perpendicular. We have Fg parallel, and then the F of K stands for kinetic friction. All right, then I tried to come up with the formula of F of G perpendicular, which is equal to F of G cos theta. All right, then the forces acting up, if you can just look at the forces acting up, we calculated yesterday because it's only the kinetic friction, which is equal to the product of mu and normal force. In order for you to calculate the normal force, you must know that you have to go back to this diagram. It will be easy for you to understand it because N is going upward, then F of G perpendicular is going downward. So these two, they are equal. If you can just have this, it's easy. You have to equate them, and it's equal to F of G perpendicular. If you can just look at that, I said I need the formula. The formula is the F of G perpendicular is equal to F of G cos theta. It's what I did here. I came here where you come across with a normal force represented by capital letter N. You just replace it by F of G cos theta. It's what I did here. And then finally, we got this value, 4,335 Newton. For what? For forces acting upward. And the one that is acting upward is only one force, which is kinetic friction. Okay. And then we calculated the forces acting down. It's what we did last time. I just need you to remember this. The f of g parallel, which is equal to f of g sine theta. The theta that we are still going to use is 35 degrees. Okay, if you can just look at that, I showed you that f of g is the same as the weight, that is the mg sine theta, which is equal to 1,800, and then 35 there multiplied by gravitational acceleration, which is approximately 9.8. Then we got 10,118 Newton, or you can say 10118 Newton. Okay, therefore, we have to find the resultant, or F net on the x-axis. What am I talking about when I'm saying x-axis? We are dealing with the inclined. In other words, we are going to ignore the n, we are going to ignore the f of g perpendicular all the time. When you come across with the inclined, you have to ignore the fg perpendicular and n them, even though they are going to take part during your calculations. All right, if you can just look at that, this is the f of x. F of x here, you can just come across with the f of g parallel and the f sub of k. If you can just look at that, they have different directions. The other one is going upward, the other one is going downward. In other words, we have to calculate the net. That is the resultant force. If you can just look at that, is what we are going to do now. Don't be confused all the time. I beg each and every learner, remember this. N and f of g, they're not going to take part in the motion, even though they are during the calculations of f of k. But you have to ignore them because we have of f of g parallel and f of k is only f of x. That is the f of x that we're talking about. And then you have to think about the thetas. Earlier here I talked about we have theta there which is equal to 0 degrees. We can just have x-axis. X-axis has what? Has positive and negative. If you need a negative work done, it's where you can just use 180 instead of 0, theta is equal to 0, you can just use your theta as 180 degrees. Okay, that is the other direction of the x-axis, where the negative side is. Okay, now we have to carry on. If you can just look at this, we have f net, which is equal to fg parallel minus f of k. What we are going to do is to substitute of the values that we have calculated earlier. Let us look at it. F of g parallel, it was 10. 1 is 10118 minus f of k. F of k, we have calculated it. We got 4335 Newton. 4435 Newton. Let me verify that before we carry on. That is 4335. 4335. All of them, they are in Newton. Don't forget that. Okay, which is equals to, you have to use your calculator. Likewise, you have to use your calculator likewise. The one that you are using now, make sure that is the one that you are going to use it in your exam room. Okay. It's 10118 minus 4335, which is equals to, we got the following. We got 5783 Newton. This is 5783 Newton. I hope you have to verify this in your calculator as well. And then, because after this, we have the F net, you can just use this F net to calculate the following. We are looking for final velocity. There are two ways that you can use. You can use a formula of work, which is W equals to F of net, change in X, cos theta. Or else you can just carry on. Let us use the work energy theorem formula. Okay. That is W net, which is equals to half MV final minus half MV initial. All of that is squared. What we have, we all know that W equals to the product of the force and the distance covered by a particular object. All right, because now we know, let me extend the page so that we can have a space. If we can just look at that, we are just going to use that F of net, change in X, cos theta. This is the work net, which is equals to F net, change in X, cos theta, which is equals to half MV final squared minus half MV initial squared. Don't be confused. This is the formula of work energy theorem, which is W net is equals to change in kinetic energy. All right. We have F net, we have calculated F net, then change in X, that is the distance is given. We have theta there, the theta that we are going to use is only on the X axis, which is equals to 0 degrees. And then we have to substitute, we're looking for V final, that is the final velocity. What we can do, we can say, let us make the V final to be the subject of the formula. Before you carry on, you have to say, therefore, we have the following. We have the following. Let me just make this to be the subject of the formula, the final velocity, that is V final. Let me just take as it is squared. I didn't do anything, which is equals to, you take whatever that you have as a initial kinetic energy to the other side. We are going to have F net change in X cos theta plus half MV initial squared. If we can just look at that, you just take as it is, it goes to the other side, it's going to change the sign. That is why we have plus half MV initial squared. Okay, therefore, before that we have to divide. I didn't do anything. I just take the half as it is, half MV, half MV. I think we are still together. Okay. This is the mathematics. You just take to the other side. You remain with the half MV, half MV final squared, and then you have to make the V final squared to be the subject of the formula. Of course, you are going to divide everything by half MV. It's what I did here. Okay, if you can just look at that, we have to substitute. Before we substitute, let me say V final, which is equals to the square root of F net change in X. If you can just look at that, I'm just copying as it is. Change of X cos theta plus half MV initial squared. If you can just look at that, I'm busy with what? I'm busy with the initial with final velocity, but I copied everything as it is. Now I just want to get the final velocity. is going to be given by the square root, big square root of f net change in x cos theta plus half mv initial squared. Okay, if you can just look at that, you have to divide. Don't forget, you divide by what? By half m. All right, we have to substitute. Let me extend my page. Let me extend my page. If you can just look at that, we have to substitute whatever that we have there. Let us go back to our data. We have to substitute everything. What I need you to do, I need you to use your calculator while I'm using mine. Okay. F net. Where are you? Is 5,787 is your F net? 5,000. 5,783. 5,783. Then what about the distance there? The distance covered. We have to go back to our data. It's where we can just find the, that is 75. That is 75. That is 75. Multiply by cos as it is, cos 0 degrees plus. Let us look at the, you have to substitute this, that is half. The mass there, we have to go back. We have to check the mass. We have to check the mass is given. It's 1,800. It's 1,800. It's 1,800. Multiplied by 1,800. Well, multiplied by 1,800. The initial velocity, do we have initial velocity there? Let us check. Let us check. Initial velocity is 0 because the object is at rest. The object is at rest. Multiply by 0 squared. Multiply by 0 squared. If you can look at that, we have okay. We have 0 squared. Don't forget, let me just extend my square root here. Divided by half. The mass there is 1,800. You have to be careful when you do substitution. You have to be sure of what you are doing. You have to check the mass is true, 1,800. And then let me extend the page so that we can have a space. Which is equals to, let us use our calculators. Let us use our calculators. We all know that where initial velocity is, everything there is 0. Everything there is 0. That is 5, 7, 8, 3, multiply by 75, which is equals to, what I'm going to do here, you can just have this. Let me just carry on so that you can see what I'm doing. Up there we have what? Because 0 is equals to 1, we can't just include it because anything that is going to be multiplied by 1 is that particular value. All right, now we are going to have what? That is 4,33725 divided by 1,800 divided by 2, which is equals to 900. which is equals to, let us do it, 4,33725 divided by 900, which is equals to 4, let me just do it, 481.91. Okay, 91. Let us use our calculator to get that. 481.91, which is equals to, the answer there is, the final velocity is 21.95 meters per second. Okay, we got our final velocity. We got our final velocity. All the time you have to check. You have to check whether you have done the correct substitution before you move to another question. Like I said earlier, this time we're going to look at the assessment. We're going to look at the assessment today. If you can just, okay. This is our assessment. I'm just going to give you only 5 minutes to complete this so that we can just move to another assessment, because we have to finish the work energy theorem today, and then we can just move on to conservative and non-conservative forces. All right, if you can just look at this, I'm giving only 5 minutes. I'm going to give you only 5 minutes. 5 minutes. A car with a mass of I'm giving only 5 minutes. A car with a mass of 1,200 is moving at a speed of 18 meters, and then on a dry day, the maximum braking force is 8,500 Newton. On a wet day, the braking force is halved. If we can just look at that, during the wet day, a braking force is halved. Okay, is the following statement true or false? Okay, on a dry day and a wet day, the distance needed to stop is 23 meters. In other words, this 23 meters here is for dry day. This 46 here is for wet day. If we can just look at that wet day, we have 46. Then the dry day, we have 23 meters. Okay. You are left with 3 minutes. 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 3 minutes left. 2 minutes left. 2 minutes left. 2 minutes left. Two minutes left. 2 minutes left. 2 minutes left. A minute left. A minute left. A minute to go. A minute to finish. A minute to finish. Time up. Time up. Let us work this together. Let me extend my page so that you can see everything that I'm going to do. Like I said earlier, all the time, when you come across with the question like this, make sure that you analyze it, you write down every given information so that they can just lead you to unknown or to the one that they need you to calculate. Okay, if we can just look at that, let us start with the given information there. I told you to say you have to write data. That is the given information. Is given information there. What do we have? A car with a mass of 1,200 kilogram. That is the mass of a car. Is equals to 1,200 in kilograms. And what else? And what else? We have a speed. That is the initial velocity. That is the initial velocity there, which is equals to 18 meters per second. This is 18 meters per second. 18 meters per second. Okay, what else? What else? What else? Okay, we've been given that we have maximum braking force of 8,500 Newton. 8,500 Newton. You have to say this is the, let me say F net. This is the F net. This is the F net. Let me just say dry so that you can see. It's a dry day. It's a dry day. It's a dry day, which is equals to 8,500. 8,500 Newton. Okay, this is the F net during a dry day, and what else? And what else? On a wet day, the braking force is halved. Okay, let me extend the page. Write down the given information again. F net. F net during the wet day. Let me write it like this. It's F net wet and F net dry. Here we have been told that this is the half. This is the half of the F net. In other words, you're going to you have to divide the F net of the dry day so that you can just get the F net of wet. In other words, it takes long to break during the wet day. We're just going to have the half of, let me say, is 8,500 Newton divided by 2, which is equals to, what are you going to get there? The half of it is 4,250 Newton. In other words, during the wet day, the F net is equals to 4,250 Newton. Okay, we have this information, and then what is it needed? What is it needed? We have to say this statement is true. If the following statement true or false, now is true or false, on a dry day and a wet day, the distance needed to stop is 23 meters and 46 meters. Okay, if you can just look at these values, they follow each other respectively. We have a dry day, which is 23 meters. We have a wet day, which is 46 meters. That is why we have different colors so that you can see what I'm talking about. Okay, if we can just look at that, we can just go back. You ask yourself, which formula am I going to use? Which formula am I going to use? Okay, you have to look at the given information first, then you look for the formula. Now, we're busy with the work energy theorem. We know that W net, which is equals to half, or let me do it like this. That is the change in what? In EK. Change in kinetic energy. Change in kinetic energy of a particular object. Now we have to substitute here. We know that W net, according to the formula of work, is the product of the force and acceleration. And force and a distance, not acceleration. Beg your pardon, it's not acceleration. That is the force and a distance. All right, if we can just look at that, we are going to have F net. Like I said, let us start with the dry day. Let me just put dry underneath there. Multiply by change in X. Multiply by cos theta. That is the x-axis, is horizontal, which is equals to half V final squared minus half mv initial squared. If you can just look at that, I just substitute the work net, which is equals to the product of F net and the displacement, because it's horizontal, that is why we have cos theta, which is equals to half mv final squared minus half mv initial squared. If you can just look at that, that is the change in kinetic energy. Change in kinetic energy, change in kinetic energy. All right. Let us substitute the values. F net dry, we have been given. We have been given this, which is 8,500. 8,500 multiplied by change in X is what we are looking for. The cos there, that is cos 0 degrees, which is equals to the half. Because of the brakes that has stopped the car, if you can just look at that, the maximum braking force is 8,500. In other words, the final velocity there is equals to 0. Okay, if you come here, you have to write the value of mass. The mass there is half 1,200, 1,200, and 0 squared. If you can just look at that, minus half 1,200 multiplied by initial velocity there is equals to what? Let us check. We have been given initial, which is 18 meters per second, which is 18. We have to say squared. We have to say squared. Okay. I just want to take the value. You can do it like this. You can just make this change in x to be the subject of the formula, or you can just substitute as it is and make this change in x to be the subject of the formula later. Okay. You can just do it like this. Okay. All right. Let us cos 0 degree is equals to 1. Okay, we're going to have 8,500. In other words, is 8,500 multiplied by change in x, which is equals to, because that one is 1, I can't just write it. And then we have half, because of the half multiplied by 1,200 multiplied by 0 squared, everything there is 0. I can't just write it. I just go straight to minus the value. You have to say half multiplied by 1,200, half multiplied by 1,200, which is 600, and then you multiply by 18 there, multiply by 600, which is, let me take it down, it's too close to that. It was 8,500 multiplied by change in x, which is equals to 194,400. Okay, if we can just look at that, let us make this to be the subject of the formula now. Therefore, change in x is equals to, that is 194,400 divided by 8,500. Then let me extend it. We are going to get the following, which is equals to divided by 8,500. This is equals to 22. That is 22. That is 22.87 meters, or you can say is equals to 23 meters. Okay, if you can just look at that, like a pattern there, you can't just have a distance of minus. We know that we have minus 22.87 meters, or you have to say is 23 meters. Okay, if you can just look at that, we got 1. Now you have to calculate. Let us prove it. Before we choose. That is 23 meters. And then let me just make the change in x to be the subject of the formula. Immediately there. Then change in x. I'm just coming from here. I just make this to be the subject of the formula. Where you find it dry, you have to write wet. In other words, we're going to have F net wet. Okay, this is equals to, I made the, okay, let me just write on top. Let me just, so that you can see. For wet day. For wet day, we have to calculate this. For wet day, therefore change in x is equals to what? We know that the final velocity there is equals to 0. We can't just copy everything. I'm just going to have what? Which is equals to the half mv initial squared divided by f net wet, because this time we're dealing with wet. This time we're dealing with wet. You ask yourself, where is it coming from? It's from this formula, where you come across with the work energy theorem. The W net is equals to change in kinetic energy. We have F net wet this time, not dry. Change in x cos theta, which is equals to half mv final squared minus half mv initial squared. Because of the final velocity that's equals to 0, we can't just copy everything. You just go straight and get this. That is the minus half mv initial squared. Okay, what else? Is there anything that is needed? Yes, we have cos theta. Your theta there is equals to 0 degrees. If you have this, it will be easy for you now to substitute. Let me extend a bit so that we can have this, which is equals to the value there, that is a half. The mass there is 1,000. Is it 1,200? Is it 1,200? Yes. I can just copy as it is. Let me just have the value there to save time, which is 19. Where is it coming from? We calculated it already before. It's 19440. 19440. 00 is 194400 divided by this time we have what? The weight there, that is the half. I think we have calculated it, which is 4,250. That is F net. That is F net multiplied by 1 is equals to, where is it coming from? From cos 0, which is equals to 4,250. We can't just, let me multiply by 1 there is the same as 4,250. You can't just take it. Let me not include it, because we know that we have calculated this. We're just trying to show that is the half there. Now we have to get the 194400 divided by 4,250, which is equals to don't forget that is minus there. We can't just have minus distance. We have to write is 45.74 meters, or you can say it's 46 meters. Okay, we have proved that the statement that is true here is A. Your A there is the answer. Your A there is your answer. That is true. That is true. Let me try to go to another example. For this one, I will just tell you it's going to be your homework. It's easy as well. A sky with a mass of 45 meters. This is 45. And then we have 15 meters. We have been given, don't forget. Let me just take another. Okay. I went back. Come on. All right. We have 15 meters. That is the distance covered. by scale the snow slope at a speed of 2.5 meters per second. In other words, we have initial velocity there, which is 2.5 meters per second. Okay, if you can just look at that, we have this 15 meters for distance. We have the initial velocity there, which is 2.5 meters per second. We have to go down. The slope there, the theta there is 25 meters, 25 degrees. The theta there is 25 degrees. And then you have to go down, that is 25 degrees. The frictional, don't forget that is horizontal. A constant frictional force of 50. In other words, we have this force that is always opposing the motion, and then you go down. If you come down here, the magnitude of the net force parallel to the slope experienced by the, remember, this is the net. This is the net. The moment you see the net, you must know that that is F net of the x-axis. All right, is given by this 179.6 Newton. That is your F net. When we use the work energy theorem, in other words, we have been guided which formula are you going to use. That is the work energy theorem. We find the maximum speed of the sky at the bottom of the slope to be. In other words, you have to calculate the final velocity. If you can just do this, you are just going to get this answer. That is number B. Okay, what is given there? You have to make sure that W net, this is your homework. I need you to do it. The answer there is 11.22. What I need you to do is to prove this. You have to go back to the formula of work energy theorem. W net is equal to the F net multiplied by change in x is given there 15 meters, and then cos of 0 degrees. Then the F net there is going to be 179.6. Then you can just say, let me just give you a clue of what I'm talking about. It's your homework. It's your homework. You have to go back and say, choose a pen there. Let me say data there. Don't forget to write your data is given there. After your data, you have to come to the equation of this work energy theorem. W net is equal to half mv final squared, don't forget, minus half mv initial squared. If you can just look at that, we are looking for what? For final velocity. What I need you to do, we know that this is equal to, let me make this to be the subject of the formula. Let me just substitute this one. We have F net first, change in x, cos theta. If you have that, we know that we have been given for the parallel, it's already there, you substitute there, which is equal to the half mv final squared minus half mv initial squared. Make that v final squared. Let me give you the formula, which is equals to, make that final velocity to be the subject of the formula. You are going to have this, which is, when it comes to that side, we are going to have F net. F net change in x cos theta plus half mv initial squared divided by half mv. If you can just look at that, I try to move from this to be the subject of the formula is v final equals to this. What I need you to do, you go back, you substitute f net, there change in x, and all the values, you are just going to get the answer. Then it will be 11.22 meters per second. Okay, thank you very much for being part and parcel of today's exercise. Tomorrow, be ready for conservative forces. We have non-conservative and conservative forces. Tomorrow, be ready for that. Thank you.